Welcome back. In this session, we deal with the second part of first unit in computer networks, physical layer. The main purpose of physical layer is to transport a raw bit stream from one machine to another. For this, various physical media is used for the actual transmissions. And each transmission medium has its own benefits in terms of bandwidth, delay, cost, and ease of installation and maintenance. So transmission media is a physical path between transmitter and receiver in a data transmission system. It is classified into two categories. So one is guided media, which is nothing but wire, in which copper wire and fiber optic is used. And the second one is unguided media, which is wireless, in which radio wave, microwave, and light wave, like lasers, are used. So this is the illustration of different types of transmission media. Now coming to guided media, we have three different categories. One is twisted pair, the second one is coaxial, and the third one is fiber optic. In this twisted pair and coaxial, they use copper wire, whereas fiber optic uses fiber optic, in which it uses light. In case of twisted pair, it consists of two insulated copper wires. One wire carries the signal, and the other wire is used for ground reference. The receiver uses the difference between the two levels. Now, what is the significance of twisting? By twisting, you can reduce or nullify the interference caused by RFI or EMI, radio frequency interference or electromagnetic interference. You can see this diagram where you have a number of, in case of A, you have number of less twists. In case of B, you have more number of twists. And effect of fractional noise or any disturbance is same on both the wires. Since the receiver takes only the difference between the two wires, the effect noise is cancelled. And these twisted pair, there are two types. One is STP, UTP. You can see this diagram. In case of STP, you have another shield over the pair, but in case of UTP, no, it's unshielded. So in STP, it is similar to UTP, but each pair covered by an additional copper braid, jacket, or foil wrap. This shielding helps protect the signals on the cables from external interference. In case of STP, its spectral bandwidth is in the range of 20 to 300 MHz, and it should be limited to a total distance of 90 meters. Coming to unshielded twisted pair, there are various categories in unshielded twisted pair. The higher category has more number of twists per centimeter, and the lower category has less number of twists per centimeter, and which it results in less crosstalk and a better quality signal over longer distances, making them more suitable for high-speed data communication. And we can see the most commonly used categories. Cat 1, here Cat means category. So it supports up to 1 Mbps, category 2 supports 4 Mbps used in token ring, and category 3 is used in 10 base T as well as token ring, 4 is used in token ring networks, as well as 5, 6, and 5 we have extended also 5E as well as 6 we have 6 extended. So these are the various categories. Coming to coaxial, a coaxial cable consists of a stiff wire as the core, central core, surrounded by insulated material. Which is a you can see in this diagram, you have a metallic shield, a copper shield, and over that you have a plastic jacket, and you can see the code also RG59. It's a special code. You look into that now, and you can see the dielectric insulator, which is around surrounded the central core. So coaxial cables are categorized by the radio government ratings. Each RG number denotes a unique set of physical properties. And here we have two things. One is thin coaxial RG58 and the second one is thick coaxial RG11. Thin coaxial cable is also referred as thin net, which is also referred as 10 base 2. Here 10 base 2 means baseband, 10 means 10 megabits per second, whereas 2 is the maximum distance it supports 200 meters. But in fact, it supports only 185 meters. And when it comes to thick coaxial or thicknet, which is referred as RG11 standard, it has an extra protective plastic cover. and this is referred as 10 base 5, 10 Mbps speed, baseband, and length of 500 meters. So the advantage is highly resistant to signal interference, support greater cable lengths. But the disadvantage is it does not bend easily and is difficult to install. Then comes fiber optic. Fiber optic cabling consists of a central glass core surrounded by several layers of protective materials. You can see here, left side A, you have a core, a glass core, or that you have a cladding material, or that you have a jacket plastic. You have a single core here actually. And light pulses are used rather than electronic signals, eliminating the problem of electrical interference. This is one of the major advantages in fiber optic. It doesn't have any type of, it neither creates EMA nor RFI. So it can transmit signals over much longer distances than coaxial and twisted pair. So this is referred as 10 base F standard. F means fiber optic, 10 means 10 Mbps, and baseband. So single mode optical fiber supports up to 10 gigabits per second up to 10 kilometers. And multi-mode optical fiber supports, it can support 100 Mbps up to 2 kilometers. It supports 1 Gbps up to 1 kilometer. It supports 10 Gbps up to 550 meters. So depending on the length, if it's less length, higher speed. If it's more length, lower speeds. And in fiber optic, the light source, there are two sources are there. One is based on light emitting diodes, and the second one is based on semiconductor lasers. And both are having some advantages as well as some disadvantages. You can see that in this table. Data rate in case of LED is low, but semiconductor laser is high. And fiber type, LED supports multi-mode, whereas semiconductor laser supports both single and multi-mode. Distance, LED shorter distances, laser longer distances. Lifetime, LED long life and the semiconductor short life. Temperature sensitivity, LED minor, whereas semiconductor is substantial. And when it comes to the cost, LED is low cost, and of course, laser is expensive. So when you look at these propagation methods, as just we have seen, there are two modes. One is single mode fiber, and we have multi-mode fiber. In multi-mode, we have step index multi-mode fiber as well as grade index multi-mode fiber. Now we can see the differences between these things. In case of single mode, the last one, it is having only maximum 8 to 10 micrometer, the fiber width with the glass width, and the outer side it is 125 micrometer. When you come to index, it is 50 to 100, and when you come to step index, it is around 200 micrometer. So single mode, you can see is traveling almost straight line, whereas graded, there's a loop, and in case of step index, we have the steps. In single mode fiber has a small diameter that allows only one mode of light to propagate. The number of light reflections are less, lowering attenuation and creating the ability for the signal to travel further. And the typical maximum length of a cable without repeater is 20 kilometers. The single mode supports longer distances normally because of less attenuation as well as less reflections. And multi-mode optical cable has a large diameter core that allows multiple modes of light to propagate. The number of light reflections increases, creating the ability for more data to pass through at a given time. And this is used for data and audio video application in LANs. Because of the high dispersion and attenuation rate, the quality of the signal is reduced over longer distances. That is why the maximum length of the cable without repeater is limited to 2 kilometers and is used for short distance applications. Next, copper wire and fiber optic. If you look into these two, the differences between these two, copper wires are inexpensive and of course already in use for a long time. The only disadvantage is it causes EMA as well as RFA, so more attenuation. In case of fiber optic, there is no effect of EMA RFA because attenuation is very less, so it supports longer distances. But the only disadvantage is expensive. Now, unguided media.